Arduino for Beginners, episode number 4, Analog Inputs. In the previous videos, we took a look at digital inputs and outputs. And by digital, that means it's either fully on or fully off, high or low. With analog, we have for analog inputs, or the analog read, it's going to be a value of anywhere between 0, which would be low, and 1023, which would be high. And you can get a reading anywhere between there. For analog write, which is going to be your PWM, your pulse width modulation, that's going to be a value of 0 to 255. Now, in this episode, we are going to take a look at inputs. In the next episode, we will take a look at the outputs. So this video, we will be dealing with an input, and that will be a range of 0 to 1023. So what we're going to do is we are going to use an LDR, light dependent resistor, and we're going to read that. And what it will do is the reading from that will determine the length of time between the flashes of this LED. Now, for what the parts we need, of course, is your Arduino board. We need 1, 2, 3, 4, 5 jumpers. We need the LDR, of course. The resistor is optional. We are using pin 13, so there is an onboard LED, so this is optional, as well as the 330 ohm resistor that will be used along with the LED. If you don't have them or don't want to use them, that's fine. You can skip that and just use the onboard LED. And then we will also need a 10K resistor. Now resistance, this resistor may vary a little depending on which LDR you use. You can play around and experiment with it. Start with about a 10K, and if you're not quite getting the reaction that you want, try a little higher and a little lower. But what we will be doing is setting it up in a voltage divider network, because that's how we're going to get our most accurate readings. If you just hooked this from power right to the Arduino analog pin, you're not going to get very reliable, well, the readings just aren't going to work hardly at all. It's not going to be reliable, and it's not going to be stable. So alright, let's go ahead and set this up. So the first thing we'll do is we'll connect our Arduino. We'll put power to the ground, and we'll put power to the positive rails. There we go. Then we will take our LDR here, and we'll put that right about in the middle. Now this has no polarity, so it does not matter which way you stick it in. Then we will take our this one here, our 10K resistor, and we want to run this to ground from one side of the LDR. Then the other side of the LDR, the side that's on the far part of the board, we're going to run that to positive. Then from the middle, the junction between our resistor and our LDR, we're going to plug in our longer jumper here. Oh, board's being a little stiff there. And we're going to run this to analog pin 0, A0 on the Arduino board. Now, if you're going to use the onboard LED, you could stop there, but I am going to go ahead and connect an external one so you can see it better. So we're going to go to digital pin 13, and we are going to take our LED. Now on my particular LED here, the if I remember right, the long terminal was the anode and the short was the cathode. If I'm pretty sure I'm remembering that correctly. So we'll put that in there. So we want to run the cathode to ground, and we're going to run that through a 330 ohm resistor to ground. Now, if you get this connected and the LED isn't flashing, you might just have the anode and cathode backwards. I have found, depending where I get these LEDs from, sometimes the anode is the longer leg, sometimes the cathode. I don't know why. They don't just do it universally, but they don't. Then we are going to connect our jumper here from pin 13 to the anode of the LED. Alright, now what we're going to do is go over and take a look at the Arduino sketch, but I already actually have it loaded on the board, so I can show this to you working here, and then we'll go over to the computer and look at the code. So plug it in. It should start working here momentarily. Alright, I think I did get that backwards. Yep, I had the anode and cathode backwards. My bad. There we go. Now it's working. Yeah, if you have that problem, just reverse it. That's all it is. It's not going to hurt it if you hooked it up the wrong way. And as you can see on the Arduino board itself, it will also flash in. As the amount of light decreases, the LED flashes faster. As the light increases, it flashes slower. Alright, well, let's go over to the computer and we'll look at the sketch for this, and it's pretty simple. We're actually just going to be using one of the examples that's in the Arduino IDE already is set up for this. So we'll just go over that real quick. So I'll catch you there in just a moment. Okay, I have the Arduino IDE opened up here. Now for this, just simply go under File, go to Examples, whoops, go down, I'm trying to remember, yeah, it's under base, no, it's under Analog, my bad, sorry there, it took me a second to remember. Yes, go under number 3 here, the Analog, and then click on Analog Input. Bring this in the screen. Now what this sketch is the only difference with how this was written was to be used with a potentiometer. We're just using basically a potentiometer that uses light instead of a dial. So this sketch is going to work perfect, and we'll go through it here. This is really easy to understand. I mean, that's, as you can see right here, that's the whole sketch. There's not much to it. So what we've got here is we're declaring first an integer. That's our sensor pin, and that's A0. Now, they could have done a define on this, and it would have worked, but like I said, I'm just using the built-in sketch for this, so I'm not going to change it. Same thing for the LED pin 13. They could have did define, or there's also what was it, internal LED or something. There's a term I can't remember right offhand that actually you don't have to put a number or anything. You just put that term in, and it automatically will use the built-in LED. But then, of course, this here, the sensor value, that we will need to use integer at. But you might as well just leave them all as integers for this. All right, then in the void setup, we're setting the pin mode of the LED as an output, of course. Then what we're doing is we're coming down here, and they've got it commented pretty good on what it's doing. What we're doing is we're making the sensor value, that's this integer here, we started out with a value of 0, and we're doing an analog read of the sensor pin, which is connected, that's on pin A0. Then what we're doing is we're digitally writing the LED pin high, so we're doing a digital write, and then we're delaying whatever that sensor value was. So it's going to be a value between 0 and 1020, what was it, 1023. Then it's going to digital write the LED pin low, and then delay that amount of time again in milliseconds. So the less light the LDR is getting, the faster the LED will blink. The more light it gets, the slower it will blink. Look at that, isn't that pretty simple? All right, Well, I think we can go ahead and wrap this episode up. In the next episode, episode 5 of Arduino for Beginners, we are going to take a look at analog outputs, or PWM. And what we will do is probably expand on what we already have set up here, so don't take that circuit apart. What we'll do is, instead of just doing a digital output of flashing the LED, what we'll do is we'll use the light, the amount, the value that we're getting from the LDR, to control the brightness of the LED. So, all right, well, make sure to subscribe so you know when the next episode comes out. And if you find this information useful, please give me a thumbs up. So, all right, hope to see you in the next episode.